November 2015, P1 question number 3, A-level differentiation shows an open tank in the shape of a rectangular prism. The vertical ends ABE and DCF are identical isosceles triangles. This one and this one, they are identical isosceles triangles. ABE is 30. Everything else is more or less given. Water is poured into the tank at a constant rate of this. So that goes to show there's going to be a chain rule question about this as well. Show that the depth of the water in the tank, this depth or this depth, is h. The volume V centimeter of the tank is given by this. So this is given, this is h, this is the height, and they are asking us to find the volume and show that it is equals to this. What we're going to do is make this shape again over here, just so that we don't mess up the original shape. These two lines are going to be parallel. And since they're parallel, this angle is also going to be 30, this angle is also going to be 30. Why? Because they're corresponding angles. Now we're going to operate inside this small triangle. So for that reason I've made it up, made another one over here. If I divide it into two parts, I know that these two sides are equal because they've given us that it's an isosceles triangle, remember? These two triangles are isosceles, this one and this one. Since these two triangles are isosceles, their base angles are equal and their corresponding sides are equal as well. So this entire angle is 120. So if I take the half of that, it's going to be 60. Now I need, in order to find the volume, what I'm going to do, basically this is the water inside the tank, somewhere over here, and at the very end of it, it's going to be like this as well. I need to find this entire prism's dimension or volume, right? What I'll do is I'll try to find the area of this and then multiply it with the length. I'll get the volume. So for area, what I'll do is I'll apply tan 60 because the opposite side I need x to h. Once I have this, I'll just double it to get the entire length. I can find that opposite side through tan 60. Tan 60 is equals to h over this height which is mentioned over here, height of the triangle. I get the value of xh as h square root of c. If this is h square root of c, I need the entire length, which is from here till here. For that, I'll multiply the side that I just got by 2, and I end up with 2 times h square root of c. Once I have that value, what I'll do is I'll use that for the volume. What is the volume of the shape? Base area into height. Base area into height. How do I find the base area? The base area doesn't have to be at the base. This is the base area. What is the concept of a prism? Whatever shape you have at the start, the same shape is at the end, right? So when you multiply the area of this shape by the height, you get the volume. Basically, because you're making that triangle appear that many times till the very end. So how do I get the base area? Half into xy into EH. Now what is the value of xy? This is xy from here till here, and EH is this value over here. Half into base into height into 40. This 40 is representing the length of the shape. So what do I get? 40 square root of 3h square, exactly what they asked us to show, right? I can show you the entire working over here. If you want to take a screenshot, or if you want to pause the video and try to understand what's going on again, or if you want to do it yourself, you can do that. Now the question says find the rate at which h is increasing when h is equals to 5. For that particular thing, what am I going to do? I'll apply chain rule. For chain rule, I have some values which are given. Take a look. Water is poured into the tank. We're talking about something liquid or gas. So that's dV by dt. Change of volume respect to time. That's 200. Find the rate at which h is increasing, height with respect to time, so we do not have dh by dt. And there is a connecting equation that we have to come up with ourselves. How do we do that? We have the volume, which is up here. If I were to differentiate it, I will be differentiating v with respect to h, right? So I've done exactly that. Once I differentiate this is the value I get. So I will plug that in over here. dV by dh is this. Now how do I write these 3 equations? I would write it in a format in which one of the values of the numerator gets cut out with the values of the denominator of the other fraction. So if you notice, I have written dh by dt over here and dv by dh over here. Why? Although I'm not exactly going to do this, but the idea is that one numerator of the fraction and another fraction's denominator should get cut out. We're not actually cutting them out, but we're supposed to write it like this. Once we have this, what do? We simply solve it just like in any other algebraic equation. We solve for dh by dt, and once we solve for dh by dt, we get stuck over here. Now this is where the question comes in handy. The question says use the value of h as 5. Remember, we will plug that in, and this is the answer that we get.